Delivering that webinar on the area of new mobility will be Stefan Roeding, who is our General Manager of Strategic Growth for NASA. And he is located, Stefan is actually located in Singapore at our offices there, where we also have an additive manufacturing center as well. I, of course, am your host today. I'll be starting off telling you a little bit about Stratasys, and then I'll also be reading off questions and asking questions at the end, potentially answering questions as well. So next slide. Really quick, I won't take too much time on this subject, but just like to introduce you to Stratasys. Stratasys is the largest manufacturer of 3D printers worldwide. We're publicly traded on the stock exchange. We have over 140,000 installations worldwide of our industrial level printers. That's excluding MakerBot. And then, of course, we have 14 offices around the globe. I'm actually located in Melbourne, and Stefan, of course, is located in Singapore, but the other blue dots are where we also have offices, and we're headquartered in Israel and Minnesota. Next slide. Like I said, we have 140,000 installations. We are publicly traded on the stock exchange. I think what's important here is that we're actually more than 31 years in business, so more than 3 decades of developing and manufacturing 3D printers. In our technology range, we actually have 5 of the 7 ASTM technologies that are available across the globe. So we are a one-stop shop for all things 3D print, especially in the area of polymers. Next slide. So as I said, the presenter today will be Stefan Roeding, who comes to us. He's our general manager out of our Singapore office. And Stefan Roeding is going to go through a lot of new mobility. So we all know cars and trains and automobiles, but we also have an emerging market of all sorts of new mobility technology. And Stefan's going to actually cover that. This is a very interesting subject matter and actually has quite a diverse application range. Stefan, how are things over in Singapore today?
It's getting better. I think most of the population here is now vaccinated, so I hope that we are all opening up and can use some of these mobility devices, which we are also presenting today.
That's perfect, Stefan. I'd like to, before you get started, say thank you for agreeing to deliver this information to us today, to us and our customers and prospects. And so I'm going to turn it over to you so that we can get right into the subject matter.
Great, thanks, Ben. Hi, everyone. As Ben just mentioned, my name is Stefan, located in Singapore here. I do ask you to keep your mobile phones ready because we have a small questionnaire in at the middle and at the end of the presentation where we need a little bit input. It's via menti.com. We will show the code and the barcode, so please keep your mobile phones with you. All right, let's quickly start, I think, which is really necessary today, with an overview of what Stratasys is all about. And I'm quite excited to really realize that we are covering most of the polymer technologies available today in the market. All of you know the PolyJet and FDM machines from Stratasys, where the Pantone validated actually printers, the PolyJets actually are really an example of design realism. We cover with the MakerBot the low entry engineering market, and with our FDM F-Series 1 to 3, we're covering from small, and with the new F770, we can cover up to 1 meter long printed parts. With our recent acquisition of RPS, we have edited SLA or SL stereolithography to our portfolio. Very nice application if you're in investment castings, if you're in tetrashell, then definitely a machine of choice, especially because of the superb surface qualities which you can achieve with SLA. But again, these machines are in design and prototyping only. On the manufacturing side, we have, of course, our FDM, our Fortus machines, especially with our flagship, the F900, which you can see on the picture here. And we are really thrilled to not only add the DLP version of Origin to our portfolio. We also have just recently announced the new H350 with our new technology called SAF, which is Selected Absorption Fusion. So this machine range is really focusing on high-end production and also larger part manufacturing. If you look at on a functional level, then we have classified the technologies in 4 different groups: design, engineering, manufacturing, serial production. And you can clearly see our jetting technology with the polujets and also the RPS are really focusing on design and going slowly over into visual prototyping engineering. Our maker bots and for sure the F123 series is really not a serious manufacturing machine when it comes to certified manufacturing. It is entry-level machine, especially the maker bots. And then we have the manufacturing side. Here, actually, we talk about the large Fortus machines, the 450, the 380, 370, and the 900s, where we can produce with the FDM technology parts in a scale of, let's say, hundreds. We all know the speed of FDM is not really fantastic, actually. That's the reason why we introduced 2 new technologies, especially the DLP and the SAF. And here we achieve production volumes in 1,000, and with this new SAF machine, we have reached parts per year of several 10,000 parts. So we have a customer aiming for 50,000 parts per year, which is a volume which has really not been often used in 3D printing, because too many people actually say at a certain volume injection molding is much cheaper and at the end of the day much faster. This is clear. But we use the SAF technology also very often as bridging technology, which means you can produce the first 20, 30,000 parts before you even have the tool ready, which means your time to market is dramatically reduced. When it comes to the technologies, as I said, the certified Stratasys, the 450, the 900s, these are the workhorses in many aviation companies. Doesn't matter if it's Boeing or Airbus or sub-suppliers. Also here, the service shop here in Singapore is using the certified manufacturing because we have to fulfill EASA and local aviation authorities specifications. But we have also a lot of decent customers like the supersonic aircraft manufacturer Boom. Maybe you have seen the latest news. United Airlines is investing in these machines as well, actually. I think they ordered 15 of them. And what you see here on the ground actually are drilling jigs, guides, prototypes, and of course, flying parts as well, as these 2 machines are certified, as well as the Ultim 9085 material. On the shop floor and on the prototyping sector, we are quite excited to represent the new F770, which is a large format printer with the reliability and the advantages of Stratasys, with a fully heated chamber, with a machine bed of 1000 by 600 by 600 millimeter, with all the connectivity you need in order to go into production. We are starting with 2 materials, with ASA and ABS. These are the 2 most common materials in the market. But clear, we see the main application, large single pieces for jigs and fixtures, large prototypes, and in a certain range also larger manufacturing. The H350, a beauty actually, coming with a new SAF technology, with an industrial grade equipment. We have an industrial piezo head. We have print heads with fluid recirculation, inline print cleaning heads, big wave powder management. That's new words for you, but I can tell you that the requirements of virgin powder in a normal operation mode is less than 30%. So you have a really fantastic reuse of material inside the machine. So there's no need for outside sieving or outside pre-preparation of powder management. Production throughput, powder bed wide fusion. It's a one-pass print and fuse. We have less consumables than other machines in the market. We have only one agent instead of two with comparable technologies. And our print head is not a consumable, it's an industrial print head, which is has a lifetime warranty or is covered under the Diamond Care from us. The applications are wide. We are starting with PA11 simply because it is a slightly better material mechanically than PA12. Plus, it is made out of reused castor oil actually. So we want to also do a little bit for our carbon footprint here in the market. Surface quality, maybe you have seen the latest announcements. We also have done some strategic partnership with Dimensions and other surface finisher. And we have fantastic color matching of these items. To me, Stratasys H350, if you are looking for large volume production, with lowest cost per part, isotropic properties, material from plant, not petrol, unique combinations of low cost per part accuracy and repeatability. And I think for service bureaus center like ours, there is no hidden cost. It is a very clear number of, you have material, you have one agent, and these are the two consumables mainly on the machine. I'm personally excited about the Stratasys Origin 1. That's a machine from the DLP sector. We have 26 materials qualified, 40 are in R&D. We have materials from Henkel, BASF, and DSM. It's an open material machine, actually. So this is one of the biggest advantages. And of course, the surface quality is superb, actually. We have done several tests with the stability of the parts. We are having a wide range of applications here, from fluid manifolds, connectors, brackets, even FST surface certified materials, which can be used in aviation as well as public transportation. As I said before, one of the main advantages in comparison to, for example, FDM is the astonishing surface quality. Which brings me to our first small Menti. I would really love to have a little bit feedback from you guys, ladies and gentlemen, on the webinar. What do you believe is your preferred technologies in order to fulfill your requirements? Maybe based on the first input, you can have already some ideas actually. So we are waiting a little bit. Please grab your phones. We have, let me just share the screen here. We have more fuse deposition modeling, VAT. Let me share
We're
the
not
screen
seeing
here.
the results.
Yeah, sorry, coming.
Okay.
I'm just have to present it on a different screen actually. So basically, most of the people still think about FDM as the application of choice, which is clear sometimes because, especially when it comes to powder bed, you need definitely a slightly different manufacturing environment because of the powder. So fuse deposition modeling or fuse filament fabrication definitely is something which you can put not only in a manufacturing environment, but also in an office space. We leave this Menti on. Please keep logging in. We will share the final outcome with you later on. Great. Interesting outcome. Let's go now to the application. After we talked about the machine, let's talk about the applications. Let's start with e-mobility for self-balancing scooters. Very nice example here again from the prototype sector. The prototypes here produce for this company 85% faster. These parts are produced on an F900 because of the size and being able to print in one piece. Tough material, nylon 6 material was used. Here, nylon 12 carbon fiber is also a good choice. A functional part, you see the topology optimized design of the part in order to reduce weight and material. That's the interesting concept over here. So it's not a wise choice, as I mentioned before, to just buy a machine and believe that you can do with one technology everything. As the application selects the technology, as I said before. So if you need ready be able to use prototypes, and FDM offers a very large machine within sophisticated materials and good quality, but of course you need support structures, which for example in powder bed fusion you don't need. Here the powder bed is the support structure. On the other side, with the FDM technologies and with our large machines, the F770 and the F900, we can produce large components. So there's no need in gluing or welding parts together. Produce parts up to 1 meter in one piece. Another very nice example is this solar-powered e-scooter. We see a lot of applications here. I just recently went into the on the web actually to see how many different e-mobility devices are available on the market, and the number is overwhelming actually. The advantages of the Stratasys large format printers actually is that you get accurate, repeatable parts from the machine. These parts here are printed with ASA material and UV stable material. Functional parts able to sustain the weight of the person. We have printed the wheels, front and tails, lights, and I think the structure beam was also printed here. Important is lead time reduction here. It's not only cost reduction because we have a much faster iteration of designs. No, it's also a much faster time to market. Another very interesting example that comes from Rinspeed with a system called MetroSnap. Interesting concept. You have a carrier vehicle and you have the so-called pods, which can be exchanged according to your requirements. So you have a basic vehicle with a passenger module or a transportation module. We have supported this company with our machines, and they have printed more than 30 interior and exterior parts for the MetroSnap concept cars with the mainly with the F450. Materials, UV stable ASA material came into place, and of course nylon 12 carbon fiber because of its stiffness to weight ratio and of course the structural strength. Very nice example here. We all know that the post-processing of FDM parts take a little bit more time compared to DLP or SAF. Otherwise, on the other hand, with the new machines, the F770 and the F900, you can produce, of course, much larger parts with no need to weld or glue parts together. E-mobility is very important, especially also on flying here. We have a clear weight concern when it comes to electrical flying, because each kilo less, of course, brings the aircraft a kilometer wider. There are a lot of UAV as well as advanced air mobility devices coming to the market. Every aerospace manufacturer, but also most of the car manufacturers are moving into air-manned vehicles. Evation actually started to print wingtip motors in 20 hours on a 450 machine. Of course, used Ultim 1010 because of the temperature requirements. In the lifespan of over the 2 years, they saved several $100,000 with Stratasys printing, simply because of the 6 months of workforce hours savings. This is something what we should never neglect. Actually, if we can optimize our manufacturing production workflow, then time saving, workman hour saving is a big contributor to the cost per part. Drone sector is huge. We had a separate presentation lately for drones, and it was highly appreciated. Actually, I just show here 1 or 2 small examples. One is here from Helico, where the world first auto following action sport drone was produced with Stratasys prints, with no more need for injection mode. Of course, the production numbers were much less. You cannot compare this with, for example, in automotive production, where you have to produce hundreds of thousands of cars per year. But again, you are able to print very complex designs with no limitations. Here again, also the soluble support material is a very important factor, because you can really wash away the support structure. Materials are suitable for functional prototype and low volume production. Of course, with FDM, you will never be able to go into mass production segments. Another example is from Leptron. That's a military lightweight UAV with less than 2.2 kilo. We have been using the Stratasys machines here with this customer in order to avoid really the traditional approach of injection molding. Costing for the tools would have been around 250,000, would have taken up to 6 months of building the tool time for the tooling for these parts. Not only has been the tooling cost been saved, but also the time to market is definitely achieved with 3D printing faster than with traditional manufacturing technologies. The core components take 48 hours to 3D print, while small components take average 6 to 8 hours to print. A very important comment here from John Oakley was really, we made approximately 200 design changes during the course of the project. And this is something where the 3D printing can play out its main advantages. Regardless of which industry you're taking, also automotive industry, within the first year of a car development, you have an average 100 changes in the car design still. And your production tools and your help tools need to follow these changes, which means you have to adapt to the design changes of your vehicle or your part. Of course, in an injection molding form or tooling would never be able to be changed so quickly. So it is really important that you can start production, low volume, find the finalized design, then you can go into mass production with manufacturing tooling. Just to give you an idea of the size, we are expecting up to 12.3% growth, which brings us to $43 billion in the range of in the time frame of 2020 to 2025. The energy sector is the largest industry on the commercial drone market. The transportation and warehouse industry will continue to be the fastest growing. If you read the latest news in warehouse management, then you will see that drones play a vital role in automated warehouses in order to stock check, in order to identify problems in the manufacturing area, or in the stocking area. And for example, here in Singapore, we recently had a new player who has developed a drone which can carry up to 3 kilo within a range of 3 kilometers to supply to the ships stopping here at the harbor with documents, medicals, and other supply. 3 kilo lifting for 3 kilometers, that's exactly the type of drones which is needed in the industry here. Another example, coming back to not e-mobility, but biological mobility, bike manufacturers. Here we have Utatrikes. The nylon carbon fiber is here material of choice, and it's a game changer for high-end use parts and prototype. We are using, again, nylon 12 carbon fiber to print faster with superior stiffness to weight performance and with a better repeatability than other 3D printing technologies. Nice comment from Ashley Guy. We see here much more applications. I had a sole presentation only for bicycles, and it's astonishing to see how many other applications are in bike production. Again, supersonic, coming over to air mobility, as I mentioned before. These gentlemen have been printing on these 3 machines, the 900, 450, and the 370, more than 100 parts, jigs, fixtures, and tools. Flying parts with Ultim 9085, certified by the aviation authorities, are also flying, as well as in many other airlines already today. So 3D printing has reached not only the aviation market, but also has reached the automotive as well as the e-mobility market, not only for prototypes, but also for additional parts. Another example, Aerotronics. Very nice example here for the application of 3D printing. Again, printing prototypes to bring parts faster to market. But we see today also more and more parts ready to use from the 3D printer onto the UAV. Besides parts, and I think you saw this during the the picture from Boom Supersonic, the opportunity with additive manufacturing and tooling is tremendously. We have seen over the last 2 years such an increase in productivity by changing tools from conventional manufacturing technologies over to additive manufacturing. You have examples as here like this tow hook. We have here done some testing, or actually the customer has done some testing here. With our nylon carbon fiber, we have a really tough material, which is going into the area of aluminum replacing aluminum. We have done some comparison with aluminum 6082 10^6. And as you can see, the performance deflection versus load test is quite interesting. We have done other examples or other materials, and even with continuous fiber, these parts have failed much earlier. The reason why, we have the best-in-class reinforced thermoplastic. We have the highest density with almost 99%. We have 35% carbon fiber, and even on FDM, the part is showing a 90% isotropy performance or condition. So it is not only important to have continuous fiber, but it's also important how is your whole 3D printing process. And here the heated chambers are playing a vital role when it comes to bonding of the polymer materials. Another examples, this time from the automotive industry, large and accurate, are jigs and fixtures. The number of jigs and fixtures we see today now in the industry in automotive as well, and you see here example from Honda, is exchanging heavy-duty plug gauges against 3D printed components. The blue item in the corner is a typical lamp plug gauge, which means it is checking the dimensional accuracy of the opening in the automotive car, in the body, and is printed, of course, now these days in nylon carbon fiber as well as ASA. We have ABS printed materials, and where needed, doweling or milling can be done in order to achieve much higher accuracy. Important point actually is you have a tool production time reduction of 40 to 60% and a cost reduction of up to 50%. Another fantastic example is the screen wiper assembly tool, which is printed in 1 meter. You see the doweling and screwing in order to achieve better accuracy than 0.1 millimeter plus minus over the length of 1 meter. This is an important tool. The tool is so light that there is no possibility to damage now the car body. Here the nylon carbon fiber plays all its advantages. It is lightweighted, but still has a superior stiffness and can be used over a longer period, of course, in the automotive sector. The use in the automotive sector also shows the assurance which customers, end-use customers, are putting into 3D printing. Trust me, in the description that an automotive company would never allow any tools which could stop SOP, start of production, or production. So you need to have a very high failure safety in order to be accepted. So the lifetime of the tool needs to be better than what most people believe is possible today in the with the technology. I will not. I could continue with many other examples, but I would like to give one more last example here on the tooling side, which is composite tooling, thermoforming tooling, and also sacrificial tooling. Actually, we have a lot of clients who are using sacrificial tooling, core printing, in order to produce special shaped components made with carbon fiber. If it's not only for exhaust systems actually, but also for more complex parts. We have the composite tooling here with Ultim 1010, which can withstand up to 213 degrees. And the parts are used with 8-bar pressure in autoclaves in order to finish the carbon fiber. Very important application because of the size of the printers of the F900, which can print this kind of large tooling. Which brings me to one more Menti. We would like to know a little bit more about what kind of applications you see more in your application or in your area of expertise. So I would love to see a little bit more input from you. And I will show the results on the screen here. As soon as something coming in. Here we are. Please take your phones and tooling is the first application. That's great to know. I think this is naturally one of the first applications. A lot of people don't see the advantages of FDM with part production. But I see here a change because of the new printers which just came to the market with the DLP, but also with the F770. Please, prototypes. Yeah, that's of course one of the main strengths of the 3D printing. Spare parts, that's also an interesting field. You can imagine how much money is spent to supply spare parts for in automotive over a time frame of 10 years. You need to keep the tools available, consider the space and the cost involved. I think spare parts is a very interesting application, and you will see automotive companies, especially when it comes to buses and to commercial vehicles, starting to change over to 3D printed parts with 3D printing. Interesting. Ben, I think I can hand over to you now.
Yes, thank you, Stefan. That is really good information. Really enjoyed the view into new mobility. Yeah, it looks like it's going to be quite an interesting world in front of us. So look, we've had a few questions. I've had a few privately sent to me that I'd like to just ask before we end the seminar, Stefan. The first one is can you elaborate a little more on composite tooling and specifically around sacrificial tooling?
It's a huge topic alone. I think we can fill one seminar just with sacrificial tooling. We see one of the main applications, of course, in the automotive sector. Low volume car production, especially, where a lot of carbon fiber molds are normally required. These molds are tremendously expensive. To create this course actually is a lot of conventional manufacturing time. So here to have the soluble support, the sacrificial cores printed allows you, I'm not sure if I have a nice picture, but I will definitely send over with the presentation some additional sacrificial tooling pictures. Is one of the technologies possible in order to optimize part design. You can create designs and cores, especially because you simply wash them away, which allows you to create very complicated shapes. When it comes to race cars, sports cars, then definitely these are the shaping tools you would like to see when it comes to tooling.
The next question that I have is around topology design or computer generated design.
Yeah, actually, I think this is
just wondering if there's any advice that you can give. They're wanting to know if there's any advice you can give on good software to achieve this outcome.
Yeah, we are. Maybe you have seen the news as well. We have a strategic partnership with Topology, a very powerful engineering software, which we have been working together with Topology to create a so-called fixture generator. So idea basically is that you load in your component and you define features you want to have in your jig or your fixture, and the software will support you in designing and building the software. A big advantage, it has features with self-supporting lattice structures within the build, which eliminates or reduces dramatically the use of support material. This, of course, brings down as well the cost for these jigs and fixtures. Another good software is today, of course, when it goes to FDM, software called eXtreme from Hexagon or MSC software. They have a very powerful module in order to analyze or predict the printability of FDM produced parts. They really brought it down to the FDM level. And of course, for other technologies like SAF or SLS, there are already today a lot of tools. Autodesk, Siemens has a very powerful tool in Siemens NX. So the number of tools are actually becoming bigger and bigger. I agree that there's still a lack of easy to use. The issue actually is if you want to print a cube, then this is what I call the printer's death. It represents everything what we hate. Flat surfaces, sharp corners, and maximum volume. Of course, if you start to design the part, you should actually ask yourself actually what are the features which the end product should fulfill. Please select the manufacturing method before you design. It is much more difficult to have an existing design and try to make it fit for AM rather than start right from the beginning with the right design on the application. Nice example from the past are, for example, in medical industries for rebreathers. If you decide on AM as the manufacturing technology, doesn't matter if it's polymer or metal, then you have a complete different approach to the part. You start right from beginning to think about an topology optimization to a bionic design, actually. So the possibilities to make the part or the end product cheaper than with conventional technologies is quite high if you start designing only after you decided how you want to produce a part.
Very good. Thank you, Stefan. Last question that I have in my list is around our new ABS CF10. Just wanting to hear a bit more information around the new ABS CF10 material.
Yeah, good point, actually. As you know, we started with nylon carbon fiber for the, let's say, more stronger materials. And the nylon carbon fiber can only be printed on the 380 or 450 or 900. But the demand was there for a tougher material. So we brought up ABS carbon fiber in order to make this material available also onto the F123 series printer, starting from the F170, 270, 370. With this material, you achieve almost similar results like with nylon carbon fiber, but it's of course available on a much lower cost printer. As well, ABS carbon fiber is also available for the MakerBots, and this makes it attractive that even on this entry-level printers, you find very sophisticated materials today. Does this answer the question, or you want?
Yeah, actually it does. Thank you very much for that. Look, so you see Stefan and my names down at the bottom. We both can be found on LinkedIn. My email address is ben.darling@stratasys.com. If you have any questions that follow after we end the webinar, please feel free to send us or send me an email, and I'm happy to get that question answered. So with that, I think what we'll do is start closing out the webinar. We do appreciate everyone coming on. Again, don't forget, there'll be an email at the end of this webinar that'll come out to you. It's a bit of a thank you from Stratasys to you. And along with that, there will be a link to the past webinars that we've held. Again, if you have any questions on anything that you review inside that link, please don't hesitate to reach out to me directly. We're happy to answer your questions. Stefan, from us here in Australia to you in Singapore, thank you very much for your time today and such wonderful information.
Great, thanks, Ben, and thanks to the audience. We will also submit these Menti results and we'll add it to the presentation. Thank you very much.
Thank you, Stefan. Thank you, everyone, for coming, and have a great day.